So if you just open your Teams on with your EIT account, then there should be like your calendar. You should be able to join the session from your calendar on the EIT Teams account.
Yeah. Let me open it. Yeah. Okay.
Okay.
Please wait a second. Let's just try and get Moteza sorted. Sorry.
Okay, no worries. While we wait, maybe the attendees can just tell us where they are attending from, which country they're located in. You can just type it in the chat box. Okay, Moteza, I will start off by just introducing the whole presentation. So I'm going to take control for now, and then when it's your turn, I'll give you control, okay?
Yeah. Thank you.
Okay, perfect. Thank you. I'm just going to share my slides from this side. Good morning, all, and thank you for joining us in today's webinar. So the webinar has now officially begun, and just to minimize any sort of disturbances, can you please switch off your notifications so we can be uninterrupted, and the instructions on how to do that are now being shown on the screen, and you can switch them back on after the presentation. So with that being said, please put any of your questions that you might have in the Q&A function box that we've got here. Or alternatively, if you don't have that option, you can go ahead and type in the chat box. So after this presentation, everyone will get a copy of the slides and the video recording of this presentation, and the certificate of attendance will be provided for free. So it will be a digital certificate, and those that stay up until the end of the presentation, I will show you as to how you can get the certificate of attendance after the presentation is complete. So just to give you a little bit of a background for those of you that don't know much about EIT. So EIT has been around for a while now, and basically we've got engineering specialists that obviously are involved in the education and the whole processes that we offer, and our programs are industry orientated. So our lecturers also are experienced and professionals in the field of engineering, and we offer world-class Australian accredited education. So we do deliver all our courses online, and for our higher education courses, you do have the option of attending in person in our school in Australia. So with that being said, these are a few examples as to why we are who we are as EIT. And as you can see, we do have a few awards under our belt as to how well we do as an institution. So if you are considering studying with us, this is, or what's being presented to you are the reasons why we are who we are. And then recently, for 2 years, we were awarded the West Australia and National Export Award for International Education and Training. So that was in 2021 as well as 2024. And then for today's topic, for today's webinar, we've got driving sustainability. So this is energy efficiency and renewable energy in the mining industry. And you will get to hear from our energy consultant, Moteza, who's joined us, and he will be giving you guys a rundown and insight about this particular topic. So without any further ado, Moteza, you can take control and begin with the presentation.
Yes, thank you. Hello, everyone. I hope you are doing well. Thank you for attending to this webinar. Today, I am presenting a webinar titled Driving Sustainability, Energy Efficiency and Renewable Energy in the Mining Industry. What I'm going to cover in this webinar are listed on this slide. I first go through the pathways to decarbonization and regulatory compliance. In this section, the mining sector's role in global decarbonization will be outlined, and the regulatory frameworks driving the transition to net zero will be examined. Then I will discuss energy efficiency strategies in mining operations. In this section, key energy consuming areas will be identified, and the strategies by which operational efficiency can be improved to reduce emissions will be discussed. Finally, I will...
Sorry to cut you off there, Moteza. Can you please take control of the slides?
Sorry, what do you mean?
Are you able, just click the back button and...
Yeah. Can you see the slide? I'm changing the slide number. Can you see this changing?
No.
Sorry to interject. Hi, Moteza. Tepiso here. You need to take control of the slides. So right at the top left of your screen, you need to click on take control, and then you'll be able to maneuver the slides for yourself.
Yeah. Now it is. Okay.
Yes, move again, please. Move the slides again. Yes, you are moving them. Thank you so much, Moteza.
Yeah. Is it okay now?
It is
yes,
okay.
It is.
Okay. All right. Finally, I will discuss integration of renewable energy in mining, the ways in which renewable energy sources can be incorporated to further reduce reliance on fossil fuels and support clearing mining operation, and will be explored. Okay, and let's get started to see what we've got in this webinar first. First of all, why decarbonization in mining industry is important. Mining is one of the highest emitting industry globally by diesel use, high electricity demand, and energy-intensive processing activities. Today, the global push for net zero by 2050 is reshaping expectation across all industries, including mining. Mining companies now face growing pressure to reduce emissions while maintaining productivity and meeting compliance requirements. Several key drivers are pushing the mining industry toward decarbonization. Regulatory pressures are increasing with clean energy regulator, safeguard mechanism, and carbon pricing frameworks requiring action. Investor demands are growing with ESG reporting and climate risk disclosure now expected as a standard practice. Community expectations are higher, with environmental stewardship and maintaining a social license to operate becoming critical for mining companies. Finally, there is cost-saving potential as energy efficiency and fuel switching can significantly reduce operational expenses by lowering emissions. Now, let's look at the opportunities in energy efficiency to cut emissions through smarter operation in mining. Firstly, haul trucks electrification and trolley assist system can significantly reduce diesel use and emissions from mobile equipment. Secondly, implementing energy efficient motors and variable speed drives can optimize power use across mining operations. Process optimization is another key area, such as improving grinding efficiency by using high pressure grinding rolls to reduce energy demand. We can also leverage waste heat recovery in mineral processing, capturing heat from kilns and furnaces for reuse. Finally, improving building management in mining camps can reduce HVAC loads and overall energy use. Now, let's look at the role of renewable energy in providing clean power for remote mining operations. Remote mines often rely on diesel generators, which are both expensive and high in emissions. By adopting on-site renewables like solar, wind, and hybrid systems, mining operations can significantly reduce their reliance on diesel. Battery storage plays a key role, enabling reliable integration of renewables and effective load management. A great example is a gold mine in Western Australia, which now operates with 54% renewables through a hybrid system. Of course, there are challenges to consider, such as intermittency, initial capital cost, and land use requirements, but the long-term benefits in cost savings and emissions reduction are substantial. Next, let's look at the regulatory compliance landscape and why understanding the legal framework is critical for mining operations. The National Greenhouse and Energy Reporting Scheme requires companies to report their emissions and energy use yearly. The safeguard mechanism sets baseline emission limit for large facilities, including many mining operations, to ensure emissions do not increase over time. Additionally, there are mining-specific requirements under state and federal environmental acts, which vary by jurisdiction. Non-compliance can lead to fines, reputational damage, and stakeholder distrust, making compliance not just a legal requirement, but a business imperative. To support compliance and transparency, companies are increasingly using carbon accounting platforms like CIMAPRO, Energy Exemplar to track, manage, and report emissions accurately. All right, let's now explore measuring and reporting emissions, moving from measurement to management. It is essential to understand Scope 1, 2, and 3 emissions. As you may know, Scope 1 covers direct on-site emissions such as diesel fuel combustions. Step 2 includes indirect emissions from purchased electricity, and Scope 3 involves upstream and downstream emissions across the supply chain and product use. Setting emission baseline and carbon intensity KPIs is critical for tracking progress and identifying reduction opportunities. To support these, tools like IoT sensors, energy audits, and digital twins can provide accurate and real-time data. Finally, frameworks such as life cycle assessment and the GHG protocol guide consistent measurement and reporting, enabling mining operations to manage emissions effectively while meeting regulatory and stakeholder expectation. All right, now let's look at how turn a strategy into action through a clear stage implementation roadmap. Stage 1 is a baseline assessment mapping current energy use and emissions across operations. Stage 2 involves feasibility studies, looking at renewable energy, integration, electrification options, and retrofit opportunities. Stage 3 is about pilot projects and scaling up. For example, electrifying a single haul road to demonstrate benefits before wider rollout. Stage 4 focuses on workforce training and developing new standard operating procedures to embed changes into daily practice. And Stage 5 involves stakeholder communications and ESG reporting, ensuring transparency, maintaining social license, and showcasing progress toward emissions reduction targets. By following this structured stage that I just mentioned, mining operations can effectively translate decarbonization strategy into measurable and practical actions. Let's look at how mining companies can fund decarbonization efforts through financing and incentives. Firstly, government incentives are available, such as funding from ARENA and the Clean Energy Finance Corporation to support renewable energy and energy efficiency projects. Secondly, companies can leverage carbon credits and offsets, including ACCUS in Australia, to help meet emissions targets while transitioning operations. There are also green loans and sustainability-linked bonds, which provide favorable financing tied to achieving emissions reduction and sustainability goals. Lastly, implementing internal carbon pricing can be a powerful strategic planning to helping prioritize projects that reduce emissions while preparing for future carbon cost exposures. These mechanisms can significantly reduce the financial barriers to implementing decarbonization initiatives in mining sector. All right, at the end of this section, I'm gonna wrap up, and this slide captures the pathway for mining operation to achieve net zero. Energy efficiency is the first pillar here, reducing operational emissions and costs through smarter equipment and processes. The second pillar is renewables, replacing high-emission energy sources with clean power to reduce reliance on diesel and grid electricity. The third pillar is compliance, ensuring operations align with regulatory frameworks while maintaining transparency and stakeholder trust. Together, these three levers, efficiency, renewables, and compliance, drive mining operations toward net zero emissions, ensuring they remain productive, competitive, and sustainable in a decarbonizing world. All right, now I'm gonna start the next section, which is about energy efficiency and the strategy to reduce energy consumption in mining industry. It is important to understand the scale of energy consumption in the mining industry globally. According to the IEA and World Bank, the mining sector accounts for around 10% of global industrial energy consumption. A significant portion of this comes from comminution, crushing and grinding of rocks, which alone uses up to 3 to 4% of global electricity annually. In mining-heavy countries like Australia, Chile, South Africa, the sector can consume 10 to 15% of national electricity, highlighting the critical role of mining in energy demand. This underlined why improving energy efficiency and adopting renewables in mining is so impactful in journey towards net zero. Greenhouse gas emissions. It is important to recognize the greenhouse gas emissions profile of the mining industry. Mining contributes to around 7 to 8% of global CO2 emissions, considering both Scope 1 and Scope 2 emissions. A significant portion of these emissions comes from diesel use in haul trucks and mobile equipment, which falls under Scope 1 emissions. Additionally, electricity use for processing and pumping contributes heavily under Scope 2 emissions. Addressing these emissions through energy efficiency, electrification, and renewable energy integration will be critical in reducing mining's climate impact while maintaining operational effectiveness. It is important to recognize mining's critical role in the energy transition. Mining is a key enabler of decarbonization by supplying essential materials such as lithium, cobalt, and nickel, which are crucial for battery technologies. Copper and rare earth elements, which are vital for wind turbines, electric vehicles, and solar technologies. However, while mining supports global decarbonization, the industry's own operation must also decarbonize to maintain social license, meet investor expectation, and ensure long-term sustainability. Many major mining companies, including Rio Tinto, BHP, and Anglo American, have made strong decarbonization commitments. These include targets such as achieving net zero scope 1 and 2 emission by 2050. They also set intermediate goals like achieving a 30% emissions reduction by 2030 to demonstrate ongoing progress. Additionally, renewable energy adoption is growing in off-grid mining operations, particularly in remote areas, helping to reduce reliance on diesel and cut emissions while maintaining operational resilience. All right, this slide shows the average energy consumption required to produce 1 ton of different metals. Copper and iron have relatively lower energy consumption, around 20 to 21 gigajoules per ton. Zinc is higher at around 47 gigajoules per ton due to the imperial smelting furnace process. Aluminium, nickel, and gold are significantly more energy intensive, requiring around 200 gigajoules per ton, largely due to low ore grades and energy-intensive extraction and processing methods. It is important to note that these values can vary depending on ore grade, mining methods, and processing technologies used. Here are some key insights on energy consumption for different metals that I just named. For copper, energy consumption is influenced by ore grade and depth. Lower ore grades require more energy for processing, increasing the energy footprint. For zinc, imperial smelting furnace ISF process is energy intensive, but alternative methods like electrolytic process may offer energy saving. For iron, energy use varies depending on production method. Blast furnace methods typically use more energy, while electric arc furnace methods are generally more energy efficient. For aluminium, the whole Herald process is highly energy intensive, primarily due to the electrolytic reduction step required in production. For nickel, energy consumption depends on ore type. Laterite ore processing is more energy demanding compared to sulfide ore processing. For gold, the low concentration of gold in ore means that significant energy is required for extraction and processing, leading to high energy intensity per ton of gold produced. These insights help identify where targeted energy efficiency measures can significantly reduce energy use and emissions within mining operations. All right, energy consumption breakdown in mining industry. This slide breaks down where energy is used in mining operations. First, diesel equipment in material handling account for around 46% of total energy use in mining. This includes haul trucks, excavators, loaders, dozers, and drills. Next, comminution uses about 25% of final energy consumption. Grinding mills are typically the largest single consumers of energy in mining. Lastly, electricity consumption in mining covers around 15% of total energy use for ventilation and other electrical needs, with an additional 14% used in supporting processes like flotation, filtering, and drying. This slide shows a practical example of energy consumption in a copper mine. Mining equipment accounts for 60% of total energy use in this copper mine, including haul trucks, excavators, drills, loaders, and dozers. Comminution makes up 36% of energy consumption. This process is essential but energy intensive in copper mining. The remaining 4% is used for other processing activities such as flotation, filtering, and drying. This breakdown highlights where energy efficiency measures in copper mining can have the greatest impact on reducing energy consumption and emission while maintaining productivity. All right, energy efficiency in the mining industry. In the mining industry is one of the most energy intensive sectors globally, accounting for around 10% of global industrial energy use. Energy expenditures in mining can range from 15 to 40% of operating cost, depending on the mineral being extracted, location, and process complexity. By improving energy efficiency, mining operation can significantly reduce operational expenses while also lowering carbon emissions, aligning with global decarbonization goals and ensuring long-term sustainability. These slides, the key areas where energy is consumed in mining operation is given. Comminution, including crushing and grinding, uses about 25% of total energy. Diesel for mobile equipment like haul trucks and drills accounts for around 46% of energy use. Ventilation in underground mines uses about 15%, making it another significant energy consumer. Pumping and dewatering operations use around 5%, and mineral processing activities like flotation and smelting also use about 5%. Ancillary services, including lighting and HVAC systems, account for around 2%. Explosives and drilling represent about 1%, and IT, communication, and automation systems use around 1%. It is important to note that comminution is often considered part of mineral processing. And when combined, energy consumption in this area can be substantial, making it a key focus for energy efficiency improvement in mining. All right, energy efficiency strategy. The first strategy that we can take in mining industry is comminution optimization. Comminution, which include crushing and grinding, and is very important in mining industry, can consume up to 50% of mine size total energy. To address these, several energy efficiency strategies can be applied. For example, using high pressure grinding rolls, HPGR, which can reduce energy used by 15 to 30% compared to traditional SAG mills. Stirred mill and vertical roller mills are more efficient for fine grinding, reducing energy consumption. Implementing a smart blast design helps optimize ore fragmentation, which reduces the energy required for grinding. For example, BHP has installed HPGRs in its copper operations and achieves around 20% energy saving. These strategies demonstrate how targeted improvements in comminution can deliver significant energy and cost savings while supporting decarbonization goals in mining. Ore sorting and pre-concentration. The problem here is that the energy is wasted when processing low-grade material. Solutions include sensor-based ore sorting using X-ray or infrared sensors to remove waste rock early in the process. Dense media separation to reconcentrate ore before it enters the grinding circuit, reducing the volume requiring energy-intensive processing. For example, a zinc mine implemented sensor-based sorting, reducing mill throughput by 30% and achieving significant energy saving. These strategies highlights how upstream interventions can lower energy use, operational costs, and emissions while improving processing efficiency. Another important energy efficiency strategy in mining is improving material handling. The problem here is that diesel-powered trucks dominate energy consumption during haulage operation. Solutions here include using electric conveyors instead of trucks for material transport, implementing autonomous haulage system, which reduce idle times and optimize routes, improving fuel efficiency. Installing regenerative braking system on downhill conveyors to recover and reuse energy. For example, a mine in Peru installed regenerative conveyors, achieving annual energy saving of 2.4 gigawatt hours. This strategy can significantly reduce diesel consumptions, cut emissions, and lower operational costs while supporting decarbonization efforts in mining. Next, ventilation, which is one of the largest energy consumers in underground minings. Using 30 to 50% of total site energy. To address these, ventilation on demand strategies can be implemented. Solutions here include installing CO, NOx, temperature, and motion sensor to monitor underground conditions. Using automation to adjust airflow based on demand, reducing unnecessary ventilation. Implementing energy efficient fans with variable speed drives. A practical example is Gold Corp's Borden mine, which reduced its ventilation energy use by 50% through VOD systems. Another important energy efficiency strategy in mining is electrification of mobile equipment. Problem here is haul trucks consume large amounts of diesel, contributing significantly to Scope 1 emissions and operational costs. Solutions here include transitioning to battery electric trucks, using trolley assist system for uphill hauls can significantly reduce fuel consumption during the most energy-intensive parts of transport. Also, implementing electric drills and loaders further reduces on-site diesel demands. This approach helps reduce GHG emissions in operations. Mining fleets can achieve up to 30% fuel cost saving, improving both environmental and financial performance. Electrification is a practical step towards reducing reliance on diesel while improving sustainability in mining operations. Another key area for improving energy efficiency in mining operations is pumping and dewatering optimization. Problem here is inefficient pumping can account for up to 20% of energy use in processing plants, making it a significant area for energy reduction. Solutions here are optimizing pump sizing and selection, ensure that pumps are not oversized, which often leads to unnecessary energy consumption. Using variable speed drives allows pumps to adjust their speed based on demand, reducing energy waste during low demand periods. Finally, a slurry transport system can leverage gravity-fed or gravitational drop design to reduce reliance on pumps altogether, further cutting energy use. Improving process plant efficiency is a key energy saving strategy. The problem here is mineral processing can consume 15 to 20% of total energy use on a mining site. Solutions here include using thickeners and tailing filtration to reduce water movement, lowering energy use in pumping, upgrading flotation cells to modern energy efficient units to reduce energy consumption during mineral separation, improving heat exchanger efficiency in leaching and solvent extraction processes, which are often energy intensive. Focusing on process plant efficiency helps reduce operating costs, lowers emissions, and supports the mining industry's transition toward a low carbon future. Another critical strategy is renewable energy integration in mining operations. The problem here is off-grid mines often rely on expensive polluting diesel generators, which increase emissions and operational costs. Solutions include installing solar PV and battery hybrid system to power daytime operations. Using wind, solar, battery, diesel hybrid systems to ensure reliable supply while reducing diesel use. Implementing solar thermal systems for water or chemical heating processes. For example, A mine in Mali installed a 20 megawatt solar plus battery hybrid system, reducing diesel use by 30%. Renewable energy integration helps mining operations reduce fuel dependency, lower emissions, and support progress toward net zero targets by saving on energy costs. Energy management systems, or EMS, are essential for sustaining energy savings in mining operations. Solutions here include implementing ISO 50001 EMS frameworks to systematically manage energy use, using smart metering dashboards and alerts to track and optimize energy performance in real time, benchmarking across multiple mine sites to identify opportunities for further efficiency improvement. For example, a mine in Canada used EMS to reduce energy use per ton by 17% over 3 years, demonstrating the potential of structured energy management to drive continuous improvement. EMS helps mining operations sustainably reduce energy use, lower emissions, and maintain operational competitiveness. Finally, beyond technology, organizational and maintenance practices play a critical role in energy efficiency. Key strategies include preventive and predictive maintenance to avoid energy loss from degraded or inefficient equipment. Operator training to improve energy conscious behaviors, such as shutting down idling equipment or optimizing operational settings. Incentivize programs to encourage workers to identify and suggest practical energy saving improvements. These practices not only reduce energy use, but also enhance operational reliability, safety, and staff management across mining sites. All right. Now I'm going to go through the third part of this webinar, which is about integration of renewable energy in mining industry. Let's look at the drivers for renewable energy adoption in mining. Decarbonization goal. Mining companies face growing pressure to meet net zero targets by 2050 for Scope 1 and Scope 2 emissions. Cost volatility, fossil fuel price fluctuation create operational uncertainty, especially in remote mines that rely on diesel. Energy autonomy, off-grid and big grid mines benefit from energy independence, reducing reliance on diesel deliveries and improving energy security. Investor and community pressure is a key factor. ESG compliance is increasingly required for financing and maintain the community's license to operate, pushing mining companies to adopt renewable solutions. Carbon pricing and regulation. As carbon pricing becomes more common, the anticipated cost associated with carbon emissions increase the financial value of low-emission technologies, making renewables more attractive for mining operations. These drivers are pushing the mining sector to integrate renewables such as solar, wind, and battery hybrids, paving the way toward a cleaner, more stable, and cost-effective energy future for mining. All right, this slide and the next two slides highlight key renewable energy sources in mining. Solar PV, which provides electricity for site operations, offices, plants, and housing. It is modular, cost-effective, and complements daytime operation well. Battery storage, which is used for load leveling, backup power, and reducing reliance on diesel. Mining operations commonly use lithium-ion or flow batteries to store excess solar energy and improve energy reliability on site. Wind turbines, which are suitable for remote mines with consistent wind resources, they help generate clean power on site, but require site-specific wind analysis before implementation. Solar collectors, which are used for water heating, process heating, and chemical leaching in mining operations. They are particularly beneficial in remote locations with high thermal demands. Green hydrogen, which can be used as the fuel for haul trucks, power generators, and heavy processing equipment in mines. It is still in the earliest stages, but holds long-term potential for decarbonizing mining operations. Hydropower, which is viable in regions where water bodies are available. It can supply reliable electricity, but it is important to consider seasonal variability when planning hydropower integration. All these technologies contribute to reducing carbon emissions and increasing energy independence in mining. For implementing renewables in mining, there are key considerations to address. The first consideration is intermittency. Solar and wind generation are variable, so energy storage or hybrid backup system are needed for reliability. Initial capex. Renewable projects often require higher upfront capital investment, but they have lower life cycle cost compared to diesel. Space requirements. Solar and wind need land area. However, solutions like carports or covering tailing area can optimize space use. Technical expertise. Many mining sites lack renewable energy design experience, requiring upskilling or partnerships. Grid availability. The proximity and reliability of the grid influence whether on-site generation or power purchase agreement are more viable. System configuration. There are several system configurations available for integrating renewables in mining. A, on-site integration. In this case, the mine directly owns and operates solar, wind, and storage system. This is well suited to off-grid or hybrid sites with high energy cost. B, hybrid systems. Diesel generators are combined with renewables and batteries. These systems are designed to minimize diesel use during period of sunlight or wind availability. Microgrids. These are localized grids that integrate multiple generation sources with smart controls. They enhance reliability and resilience, particularly in remote mining locations. The power purchase agreements, PPAS. In this model, a third party builds, owns, and operates the renewable system, while the mining company pays only for electricity use. This structure avoids upfront capital expenditure for a mining company while still providing the benefits of renewable integration. Selecting the right configuration depends on the mine's location, energy cost, and operational strategy. As we wrap up, it is important to remember the principle reduce before you replace. Before integrating renewable energy solutions, mining operations should first address energy efficiency and optimization opportunities across existing systems. Many mining systems currently operate below optimal efficiency due to outdated equipment, poor process control, or unoptimized operational practices. By focusing first on process optimization, equipment upgrades, ventilation efficiency, energy management system, and comminution efficiency, sites can reduce their overall energy demand. This approach reduces the size and the cost of renewable energy systems needed, shortens payback periods, and maximizes return on investment. In short, efficiency first lays the foundation for successful renewable integration in mining operations. This ensures that when we invest in renewables, they are used in the most efficient and important way possible. This approach not only leads to immediate cost savings and lower emissions, but it also ensures that any future investments in renewable energy systems are appropriately sized and more cost effective. In essence, energy efficiency lays the groundwork for a more sustainable and financially viable transition to renewables. It helps mining operations hedge against volatile fuel prices, reduce GHG emissions, and lower energy costs. By focusing on energy efficiency first, we prepare the mining sector to transition towards net zero in a way that is practical, cost-effective, and aligned with sustainability goals. By implementing energy-efficient technologies such as high-pressure grinding rolls, variable speed drives, and ventilation on demand systems, mining companies can significantly reduce their overall energy demand. Additionally, adopting data-driven process optimization strategies enables them to identify inefficiencies and adjust operations in real time. These combined measures can deliver energy demand reduction of 10 to 30%, translating to lower operational costs, reduced emissions, and a more resilient mining operation prepared for transition toward net zero. Thank you so much for your attention. I hope it was a helpful presentation for you. I would be happy to hear your question, your comments. Thank you again.
Thank you so much, Morteza. That was very insightful, and obviously you are knowledgeable about this, so we thank you for all the insights you've given us today. So as we finish off, these are the upcoming courses that are currently on schedule here at EIT. So you can go ahead and basically reach out to us if you are interested in any one of these courses. I will leave my email address in the chat after this, so you guys can just have it in case you do have any inquiries. And the certificate of attendance will be given to the participants that have attended this course. So here's a QR code and a link. So basically you'll need to fill out a survey after this, and then that will obviously make you eligible to receive the certificate of attendance. And once again, thank you all for attending this presentation. And then so the courses that cover these topics are listed here, and the professional certificates of competency are our 3-month courses, and then our advanced diplomas, those can range anywhere from 18 to 24 months, and then obviously our bachelors are a 36-month course. So you can go ahead and take a look at that. And then for now, we can open up the floor for some questions. If anyone does have any questions, you can pop them in the Q&A box. However, if you do not have that function, you can always just pop them in the chat box, and then either I or Morteza, if it is a technical question, Morteza will be able to answer that. And then if it's just general questions about inquiries, I'll be able to take that. So we'll give you guys about a minute or so to ask the questions, and then Morteza will go ahead and answer your questions. Thank you so much for your attendance.
Yeah.
Okay, Morteza, I see we've got a few questions here.
Yeah. A friend asked a question regarding what is the best way to manage efficient renewable energy. I believe the first thing that we need to do is finding the best technology that is suitable for the site. You know, we sometimes should think about whether wind or solar, which one is more suitable for the site. And this is the best thing that we can do to manage the renewable energy. But each of these technology have their own management ways. For example, when we have solar PV system, if we want to increase the system performance, we have to select the best tracking system, the best inverter, and pay attention to soiling. Such actions like these can improve the system efficiency and also for the wind systems. But as I mentioned, the most important thing that you should do is selecting the best technology for the site. This is my opinion regarding the question that my friends asked. And another question I see here, a friend as such innovating and practical energy efficiency strategy being discussed, though I believe they do come with limitation and may not be easily adopted across all mine settings. What energy efficient strategy have been introduced trail between the mineral exploration stage, which relies on predominantly fossil fuel powered and electric drill rigs. Yes, I agree with you. Actually, these strategies that I mentioned sometimes is quite hard to implement them. Because the most important thing that we should pay attention about and when we want to implement this strategy is not interventing the industry and the production. It's very important. Sometimes we want to decrease the energy consumption, but we don't care about the production. And this might be very harmful for industry. So when we want to implement this strategy, we first need to study deeply to realize that this strategy can be implemented in industry. And yes, some of this strategy that I mentioned might not be able to be implemented. So you need to go further through this system to realize which one is the best to implement. I hope I could answer your question.
Thank you for that, Mortez. So there's another question from one of the attendees, which I think you might not have seen. And so basically, they were asking about, so the question is integrating wind tech into mining as an energy source to reduce reliance on diesel. So he's basically asking, okay, that just doesn't the noise from the mine affect the wind turbines and all in as much as the turning of the turbines that produce the noise too?
Yeah, if I understood the question correctly, yeah, I see the question. My question is into the mining and affect wind turbine all in as much as the turning of the turbine produce noise too, and is they too looking at downside of the integration to reduce non-diesel doesn't the noise. Actually, my knowledge regarding the wind turbine is limited. I cannot answer this question comprehensively, but I believe the noises that we have in mines might not affect the wind turbine's performance, but I am not sure about that. And my knowledge regarding this question is not enough to answer your question, but thank you so much for your question.
Okay. And then, so we've got another 5 minutes, and then we're gonna have to wrap this up. So the next question, I don't know if you saw it, where the attendee asked, would you recommend geothermal or solar energy looking at the environment and efficiency requirements? How about the nuclear energy versus fuel in mining sectors?
Actually, I don't recommend geothermal energy because the cost of geothermal energy is quite high. But again, it depends on the location that we want to use geothermal energy. And it depends on the site. We need to do some feasibility study to make sure that this energy is suitable for the mine. But I cannot say definitely this geothermal energy is not suitable for mining industry. As I said, case by case is different. And we need to study this source of energy to make sure that it's suitable for the mining industry that we want to implement it. And regarding the nuclear energy, actually, I have no idea about the nuclear energy. I apologize for that.
Okay, and then one more question. I think we've got time for one last question. Okay, so Isaac's Oscar is asking, what is the future of biofuel as an alternative to crude diesel in mining? Do we have cases where it is fully utilized?
Actually, as far as I know, we have some cases regarding biofuels, but I believe these cases are still in laboratory and they are not complete that we can use it in industry or anywhere else. And I still believe we need to work on them further because biofuel is something that we should work on that further, because when we are talking about the biofuel, we should bear in mind that the system that once worked with biofuel also needs some modifications. For example, the engine that want to use the biofuel needs some modification, and this modification might affect the system performance greatly. But I saw some studies regarding these biofuels, and I am not sure if we've got biofuel in real cases and in industry.
Thank you for that, Morteza. So this brings us to the end of our webinar today. And once again, thank you all for attending, and everything will be sent through to you guys latest by Monday. So just keep an eye out on your email. And once again, thank you, Murteza. Have yourself
No
a wonderful
worries.
day. And thank you all to the attendees. Have a great day ahead. Bye.
Thanks, everyone. Have a great weekend. Bye.